This video is about the motions of the moon, moon phases, and eclipses. There are 4 pages in the student guide about the lunar phases. The first page has the vocabulary terms and the phases and eclipses lecture outline. The next page in the student guide is about telling the difference between a waxing phase, where you see more and more of the lit side over time, and the waning phase, where you see less and less of the lit side over time. The third page in the student guide steps you through from where the moon is in its orbit for a waxing crescent phase to how it looks like a crescent sliver with the lit part on the right side of the moon. The fourth page in the student guide guides you through from where the moon is in its orbit for a waning gibbous phase to how it looks like an oval with the lit part on the left side of the moon. Now back to the first page. The first couple of vocabulary terms are similar to the sidereal day and solar day terms we saw in the previous lecture. The sidereal period for the moon is the time it takes to execute a full 360-degree orbit around the Earth, which is 27.3 days. However, because the Earth is moving around the Sun in a counterclockwise fashion, as seen from high above the North Pole, and the moon orbits the Earth in the same counterclockwise direction, it takes about another 2 days to get the Sun and Moon lined back up to where they were for the previous occurrence of a given phase. The Moon has to move through almost 390 degrees around the Earth for the synodic period. That is why the lunar phase cycle is 29.5 days long. The lunar phase cycle is why a month on our calendars today are about 30 days long. The last 5 vocabulary terms have to do with eclipses. The first moon motion we'll look at is the moon spinning on its axis. The moon spins or rotates once on its axis for every 1 orbit or revolution around the Earth. That is why we see only one side of the moon facing the Earth. That is shown on the left. If the moon did not spin on its axis, then there would be some times in the month that we could see the other side of the moon. Below that is an animation showing that the moon spins just enough to keep one side of the moon facing us. That is why all of the Apollo manned missions to the moon landed on the near side of the moon to keep in contact with the Earth. Someone on the far side of the moon will never see the Earth. The animation does not show the Earth spinning very fast, once every 24 hours. If we here in the US see the moon in a waxing gibbous phase, someone on the opposite side of the Earth, say China or Australia, will also see a waxing gibbous phase 12 hours later. Now for the phases of the moon. The phases of the moon are caused by the changing angle between the sun and moon on our sky. That changing angle between the sun and moon on our sky changes how much of the lit side of the moon we see. The moon-sun angles are given in the inner ring of the drawing. When the angle is less than 90 degrees, we see a crescent phase, or less than half of its lit side facing us. Since the moon is a sphere, the boundary between the day and the night on the moon is always curved. When the angle is more than 90 degrees, we see a gibbous phase, which means a shape that is rounded outward on both sides, like an oval. We see more than half of its lit side facing us. Again, the boundary between day and night on the moon is curved because the moon is a sphere. What we see on the Earth is shown in the outer ring. The picture is definitely not to scale. Notice the letters A, B, C, and D on the Earth at the center of the picture. A person at the position A would see the sun on their meridian. The Earth spins counterclockwise. 6 hours later, the person would be at position B and would see the sun setting in the west. 6 hours later, the person would be at position C and it would be midnight, facing directly away from the sun. 6 hours later, the person would be at position D and would see the sun rising in the east. The next picture below shows the views from the ground for the different times of day and the angles the moon makes with the various phases. At noon, observer A sees the sun on the meridian. The new moon is when the moon is nearly lined up with the sun. Usually the new moon is above or below the Earth-Sun line, so we do not have a solar eclipse at every new moon. Again, none of these pictures are at true scale. In these pictures, you are standing on the green ground of a flat Earth facing south. East will be on your left and west will be on your right. Everything rises in the east, gets up highest when it crosses the meridian, and then sets in the west. Of course, the rising and setting of the sun and moon are actually due to the Earth spinning. Since it takes the Earth 24 hours to spin 360 degrees, the Earth takes 6 hours to spin 90 degrees. If we look at observer A picture in the top left, you see that the new moon phase is less than 5 degrees from the sun. It rises and sets with the sun, being at most a few minutes different from the sun. A few days later, the moon would be at the waxing crescent position shown here. The waxing crescent moon, shown here at 45 degrees from the sun, would be 3 hours behind the sun. It would rise at 9 a.m., cross the meridian at 3 p.m., and it would set at 9 p.m. A few days later, the first quarter moon is at 90 degrees from the sun. It is 6 hours behind the sun, so it is rising at noon, gets up highest crossing the meridian at sunset, or 6 p.m., as shown in the top right observer B picture, and then sets at midnight, as shown in the bottom right observer C picture. A few days later, the moon would be at the waxing gibbous position shown here. The waxing gibbous phase, shown here at 135 degrees from the sun, would be 9 hours behind the sun. It would rise at 3 p.m., cross the meridian at 9 p.m., and set at 3 a.m. The full moon is nearly 180 degrees from the sun. Usually the full moon is above or below the Earth's sun line, so we do not have a lunar eclipse at every full moon. The full moon is 12 hours behind the sun, so it is rising at sunset, as shown in the top right observer B picture, gets up highest at midnight, crossing the meridian at midnight, as in the observer C bottom right picture, and then sets in the west at sunrise, as in the observer D bottom left picture. The waning gibbous is lit on the left side. A few days after the full moon, it would be at the 135 degree angle shown here. It would be 9 hours ahead of the sun. It would rise at 9 p.m., cross the meridian at 3 a.m., and set at 9 a.m. A few days later, the moon would be at third quarter, which is lit on the left side. It would be 90 degrees from the sun, and it would be 6 hours ahead of the sun. It would rise at midnight, as shown in the observer right, observer C picture, cross the meridian at sunrise, as in the lower left observer D picture, and set at noon, as in the observer A picture. A few days later, the moon would be at the waning crescent picture, shown here of 45 degrees from the sun. The waning crescent moon is lit on the left side. The waning crescent moon shown here is 3 hours ahead of the sun, so it rises at 3 a.m., crosses the meridian at 9 a.m., and sets at 3 p.m. A few days later, the moon is back at the new moon phase to start the cycle again. Note that each major phase, new, first quarter, full, and third quarter, are about 1 week apart from each other, 4 major phases every month. Also note that the bigger is the angle between the sun and the moon, the more of the lit side we see. The phases of the moon are due to the angle between the sun and the moon, not the Earth's shadow. Because every shadow points directly away from, or opposite, the light source, the Earth's shadow points 180 degrees away from the sun. Also, the darkest part of the Earth's shadow, the umbra, tapers or narrows down to a point like a cone. If the Earth's shadow caused the phases, all of the phases, except full phase, would have to be between 179 and 180 degrees from the sun, instead of the huge range of angles we actually see. That means that all those phases would be 12 hours behind the sun, instead of the really different times we actually see. Because the shadow model predicts very incorrect angles and time of day for the phases, the shadow model is wrong. The phases of the moon are actually due to the angle between the sun and moon. Further down are a couple of animations. The one on the left is for a waxing crescent moon, and the one on the right is for a waxing gibbous moon. The ground view, on Earth view, part of the animation shows how the waxing phases trail behind the sun across the sky. The space view shows how the Earth spin positions the observer at various angles with respect to the sun. At noon, our part of the Earth is facing right toward the sun. 6 hours later, the counterclockwise spin of the Earth places our part of the Earth at a 90-degree angle with respect to the sun. 6 hours after that, the counterclockwise spin positions us to face directly away from the sun at midnight. 6 hours after that, the counterclockwise spin positions us at a 90-degree angle with respect to the sun.